investigating the pumice rock. The pumice is a rock that can form during volcanic eruptions. We'll use it to investigate the size of pieces that break off landforms. I'll give each group, which we're going to do this a little bit differently. We're going to do this as a whole class. We have these two rocks right here, lava rocks, and we are going to rub them together. Each person gets 5 rubs. Okay, this is going to say 10, but it's because our groups are bigger, so we have less rubs to rub them together. Okay, so we're going to rub the rocks together, and as we're doing that, we're going to want to look at what do you notice about the pieces that broke off the rock, okay? And then it says visualize a whole landform made of pumice rock and being hit by water. What would the pieces that break off the landform look like? So I want you to think about that. So what I'm going to do is I'm going to close my computer. I'm going to turn on my whiteboard so we can see the rocks. And we're going to take turns rubbing the rocks together, okay? So we're going to start with Braxton. So remember what we talked about, or what our questions were. What did you notice about the pieces that broke off the rock? What did you notice? Avery.
They're very tiny pieces.
They're very tiny pieces, okay. AJ, what do you notice?
Maybe not. That might be like a way how the lava, sand that's always black. It looks like sand and it's like black.
So you're talking about like the black sand beaches or whatever,
Yeah.
and how they have, it comes from lava rock, and this is what you think it would look like?
Yeah.
Okay. Verona, what do you think?
The little pieces, that there's little pieces in big chunks, and that all the little pieces when they come together it looks like one big chunk.
Yeah. So you're saying that there's some bigger pieces. Would you guys agree? Are those a couple bigger pieces?
Yeah.
There's another bigger piece. Okay. All right, Brooklyn.
There's sand now.
It's like sand. It looks like sand. Good. Koi.
Like some came out like already rounded.
Oh, yeah. So it's rounding that rock together a little bit more, isn't it? Then like all the sharp edges, it's rounding it up. Good. Ashlyn.
It came from lava.
Yeah, came from lava. So it says visualize. So in your mind, I want you to think, close your eyes. Visualize a whole landform made of pumice rock being hit by water. What would the pieces that break off the landform look like? Okay, can you just envision this beach that looks like this? Okay, all right, go ahead and open your eyes. So it says, let's try to answer the question we've been investigating. How could water change a landform even though landforms are made of hard rock? Avery?
Waves crash in, so maybe the waves are very hard when you crash into them. So that's why maybe how rock falls off.
So you're saying when water hits a landform, it's causing tiny pieces of landform to break off? Yeah, good. Koi, what do you think?
Like same thing as Avery, but it's a little different. Like when it hits the landform, it doesn't have to be big or small.
Okay.
It can be like in the middle.
Okay.
It can be like really big chunks of the landform.
Good. Okay. Brooklyn?
That maybe it like crashed against the rocks and stuff and turned into the sand.
Okay. Great. We have a key concept. I'm going to read it and then you guys can't see it, just kidding. We have a key concept. Okay, I'm going to read it and then you guys are going to repeat it. Water hitting a landform causes tiny pieces of the landform to break off. Your turn.
Water hitting a landform causes tiny pieces of the landform to break off.
Awesome. Okay, so making sense of how landforms erode. That's a good word. Everybody say erode.
Erode.
How did the recreation...
Recreation.
Sorry, yes, thank you. How did the recreation center cliff change? Remember from the beginning of this unit? How did this cliff change? Tate?
Maybe because maybe there was like a giant storm and like giant waves came up to the rock and then it smashed the big huge rocks off and now it's like 1 meter away.
Yeah. Oh, good. You had your measurement in there and everything. Great job. Okay. All right. And geologists have been studying this landform, right? And how it's eroding and changing the look of the cliff. Correct? Do you guys agree with that?
Yeah.
Okay. So it says this chart lists activities.
So I'm gonna say how many on top, how many on bottom, how many in all. You ready? How many on top?
10.
How many on bottom?
4.
How many in all?
14.
14. Grace, will you go ahead and flip up 14 for us? Nice job. Now will you push down 13, 15, 17, 18, 19, 20? Nope, not 14. 13, 15, 17, 18. You have to push that in front. Thank you, Grace. And 20. Thank you. Perfect. All right, here we go. How many on top?
10.
How many on bottom?
2.
How many in all?
12.
Keziah, go flip 12 up. How many on top?
10.
How many on bottom?
10.
There she is. Nice job. How many in all?
20.
20. Otis, go find 20. Oh yeah, just leave it. There you go. Will you just pull it up? Like leave it still in there in the front. Thanks, Otis. Okay, friends, here we go. How many on top? How many on bottom?
1.
How many in all?
11.
Lila, will you find 11? Give me a yes, I agree, or no, I don't. All right. How many on top?
10.
How many on bottom?
17. 17.
Oh, you're right. Sorry. I blocked that one in. My fault. How many? Let's look.
5,
5, 6, 7. My fault. How many in all?
17.
Good job. Trevor, will you find 17? I noticed he counted on. He started at 14, 15, 16, 17. Good thinking, Trevor. How many on top?
10.
How many on bottom?
9.
How many in all?
19.
Ollie, will you go find 19 for us?
19 is so close. Yeah, 99.
Ooh, nice job. How many on top?
10.
How many on bottom?
6.
How many in all?
16.
Beckett, find it. How many on top, friends?
10.
Is 10 already flipped up?
Yeah.
It's already up. How many on bottom?
10. 0.
0. Does that match 10?
Yeah.
One full group of 10. And then a 0. 1 and a 0 makes
10.
10. How many in all? Oh, just kidding. How many on top?
10.
How many on bottom?
4. 5.
5. How many in all?
15.
15. Josiah, will you find 15? Orange, oh, it's your turn. Lexi.
My turn, Daddy.
Watch out. Be careful.
What?
Porter put away, Sophia put away, Connor put away, Jenna put away. Okay, friends, how many do we have on top?
10.
How many on bottom?
8.
8. How many in all? 18. 8 and go find 18.
I'm done.
Quickly, Aiden. There you go. 18, honey. Where's 18? That's the point. There you go. How'd you know that was 18? it again, louder.
Because August said that 18 is better than 18.
Otis said, okay, good. We're ready. We are talking about 3D shapes. We're talking about 3D shapes. So we're gonna review. My 3D shapes are on these cards, so they look kind of flat, but they're not. They are 3-dimensional shapes. Are you ready? One of my favorite lessons is coming up where I teach you how to draw the 3D shapes. It's one of my favorite ones. Okay, here we go. Ready? What shape is this? Sphere. It's a sphere. This is called a rectangular prism. Say it with me. Rectangular prism. And can I show you what a rectangular prism looks like?
Yeah.
Addie, will you grab the Kleenex box over there and bring it over here?
Because it's a rectangular prism.
That's right. Actually, you know what? Just hold it up. Look, friends. That is a rectangular prism. It's rectangular, right? And they call it a prism. I'm not going to get into why, because a lot of details in that. But rectangular. Oh, good, good. All right, how about this one? Anyone know?
Cone.
See the cone? See how it's rounded? Cube. Look at this Kleenex box. What is that? It's a cube. It's a cube. How about, oh, this one's tricky. Close. That one's just a square though. It's flat. This is a pyramid. Pyramids have a square bottom. Okay, they have a square bottom. We'll talk about it when we get there. Triangular prism. Triangular. You know what? We made this earlier with our no, what was called? You see that blue square? What do we call those? Oh man. Well, we made them with those. Remember that blue square? Polydrons. Polydrons.
What's a polygon?
That blue square. Remember you hooked them together and it made a cube?
Yeah.
The blue square right there in the black pocket chart. You see it? Yeah. All right. We're going to get to it. And this is our wonderful shape. Cylinder. It's a cylinder. And a cylinder. Do you remember how I showed you how to do that?
Yeah.
What do you do, Addie?
You take a rectangle and I also saw a song about solid shapes.
I should probably find one so we can sing it. I'll do that. I love that. That's a great idea. So a cylinder, I take a piece of paper, rectangular, right? And then what do I do? Roll it up. Do you remember bringing me a cylinder?
Yeah.
And then I do a little taping job, don't I? And then it's a cylinder. Circle face. Circle face. Can you think of a cylinder? What's a cylinder? Like, what are some examples of a cylinder? I'm going to write them up here, and then I'm going to make a poster, and we'll hang them up.
Okay.
Okay? So what's a cylinder? I mean, an example of a cylinder.
What's this mysterious?
Cylinder. Addie, you are rearing to go today, sweetie. So what do you think?
A cylinder has two faces that are circles.
That's correct. It does. It has two circle faces. Remember the flat part of the shape? What's an example of a cylinder? So we'll say two flat circle faces. What else? Beckett, what else do you want to tell me? Pass. Sabrina?
Cylinders can roll.
They roll. What else? Porter.
Cylinders are a
3D shape. 3-dimensional. 3D solid.